All right, guys, we are starting Unit 4 today. Okay, so it's all about polynomials, but we're going to first talk about our properties of exponents. So let's talk about what an exponent even is, first of all. If I have something like a to the n power, this a represents what we call the base, and the n represents the exponent. So the base is just whatever is being raised to the exponent or to the power. Okay, so let's look at a couple examples. So I'm going to write out this exponential form. I'm going to write out base and then expanded form. And we're going to look at a couple different examples. Okay, so for exponential form, let's look at negative 2x to the third power. So I want to say, okay, well, if I have negative 2x to the third, what is the base of that? So the base is what has the exponent. So if you want to write right here, the base is what has the exponent. So the only thing that has an exponent is the x. So the x is being raised to the power of 3. So when it says expanded form, I just want to expand out. So I have negative 2 times, and I have x to the third. So I'm going to write the x 3 times. I have 3 x's. So we're going to look at just 3 different versions here. So now let's look at if I have negative, and then I have 2x to the third power. Okay, so you say, well, what's the base? What part has the exponent? That would just be the 2x. So I'm going to write 2x. That's just the base. So then the expanded form, I have this negative, and then I have 2x 3 times. So I want you to notice the difference here. This 3 is just on the x. This 3 is on both the 2 and the x, so they each get written 3 times. Let's look at one more. Now I have everything is being raised to the third power. So the negative 2x is the base, which means the expanded form would be negative 2x, negative 2x, negative 2x. So I have it 3 different times. Okay, so we're going to talk about the different properties now. So I'm going to write property, and then we're going to do 2 examples of each one. One with a number, and one with a letter. So if you just want to write property, example, example. Okay, so the first property. The first property is called product of powers. Now, you don't have to memorize the words here, but you definitely have to know what these properties mean. Okay, so product of powers. If I have something like 3 squared times 3 to the 4th. 3 squared times 3 to the 4th. What I do with those powers is I add them. So I'm going to write 3 squared plus 4. I add the powers, and that would equal 3 to the 6th. So let's do one with letters now. If I did something like p squared times p to the 9th, same thing. I would add the powers, so it would be p to the 2 plus 9, which would equal p to the 11th. So if you see the base, remember this is the base and this is the base. If both the bases are the same and I'm multiplying, I'm going to add the exponents. And this is how you can think of it. Let's look at the p's. I'll do some x's here. I'll do a little smaller one. If I have x squared and x cubed, and I write that out, this would be x times x, and this would be x, x, and then a third one. Okay, so look at how many total ones you have. I have 2 here, and I have 3 here, which equals x to the 5th. That's where that addition comes from. Okay, let's look at the second one. Let's look at quotient of powers. Quotient of powers. So if I have 9 to the 5th divided by 9 to the 2nd. If I'm dividing here, I'm going to subtract. So this becomes 5 minus 2, which would equal 9 to the 3rd. So division, I subtract. And you always do the top minus the bottom. Doesn't matter if the bigger one's on top or whatever. You always do the top one minus the bottom one. So if I was doing some letters, let's do b to the 6th over b to the 4th. I would have b raised to the 6 minus 4, which would be b squared. Okay, the third one, negative exponents. Negative exponents. So if they give you something like 3 to the negative 5, you never want to leave exponents negative. You always want to make them positive. So what I'm going to do is, in order to make this positive, it actually moves to the denominator and becomes a positive 5. So now I have 1 over 3 to the 5th. So if I had a letter, let's say b to the negative 3, I can make that positive by moving it to the denominator. Now, also here, I want to do the other way. What if I had 1 over 4 to the negative 2? I have a negative exponent, but I'm in the denominator. It just moves up to the numerator. So this becomes 4 to the positive 2. Same thing here. If I had 1 over x to the negative 3, if I want to make this positive, I move it up and it becomes x to the 3rd. Okay, so you always want to leave your answers in positive exponents. Okay, next one. We've got several, so just stick with me right now. Power of a power. Okay, so power of a power. This is like if I have 3 squared. Here's the power or the exponent, and it's raised to another exponent or power. Okay, so here I multiply. So this becomes 3 to the 2 times 3, which equals 3 to the 6th. Okay, I multiply them. So if I have a to the 2nd, and that's all raised to the 4th, that would be a to the 2 times 4, which equals a to the 8th. Okay, the next one. Power of a product. And on that same line, I'm going to do power of a quotient because these are extremely similar. So power of a product. This means, let's say I have 2x in parentheses, and it's all raised to the 4th power. So at the beginning, we wrote out our expanded form. We did 2x times 2x times 2x times 2x 4 times. But what I can also do here is the 4 can go to the 2 and also to the x. Now, we can simplify this, which we're going to always do when we start doing our examples. So this would be 2 to the 4th is 16, x to the 4th. Okay, and if you don't know how to do that on your calculator, let me show you real quick. So I would put in the 2 first, and then you use this button over here, the upside down V. And then the yellow ones are a little bit different. Mine's older. So I would do 2 to the 4th is 16. So remember, think about what that even means. 2 to the 4th, that's 2 times 2 times 2 times 2. So 4 2s. Okay, so for power of a quotient, similar situation. I'm going to just do some letters here. X over y squared. Same thing. The square, the 2, goes to the x and also to the y. So it would be x squared over y squared. Let's do one more here. I'm going to switch colors so you don't get mixed up. Let's do a over b to the negative 5. So I'm combining two different properties here. First thing I want to do is this one. I want to put the negative 5 to the a and also to the b. So I'll write it right here. A to the negative 5, b to the negative 5. But remember, we don't want to leave any negative exponents, so we want to make them positive. If this is negative, it's going to move to the bottom. And if this is negative, it's going to move to the top. So this is going to become b to the 5th over a to the 5th. And that's it. That would be your answer. So you're going to have something like that where they both are negative and they basically switch places. The last property, which I'm just going to go right here, the last property is the 0 power property. The 0 power property just means if the exponent is 0 or the power is 0, it always equals 1. So 7 to the 0 power is 1. If I had x to the 0 power, that would equal 1. If I have x, y, all to the 0 power, remember, this 0 goes to both of those. So I would have x to the 0, y to the 0, and both of those would equal 1. 1 times 1 is just 1. Okay, so when you see that 0, remember, anything with that 0 power is 1. Okay, so we're going to do some examples here. And basically everything we're just going to be simplifying. So I'm going to write simplify here, because that's what we're going to do, is we're going to use our properties, our exponent properties, and we're just going to simplify. So let's start out. I'm just going to go number 1, 8x to the 0. And I'm just going to highlight underneath so you can see the example. Okay, so 8x to the 0. Okay, so look at x to the 0 is just 1. So this becomes 8 times 1, because these are just being multiplied together, equals 8. So that would be my answer. So some of them are going to be real quick. Some of them are going to take up a little bit more space. Let's do another 0 one. Okay, so here I have 3 times x to the 0. Well, x to the 0 is just 1, so that just leaves me with 3. On this one, y to the 0 is just 1, so that just leaves me with 2. And now I have 3 times 2 is 6. Okay, number 3. So when you first look at this and you see two things with this exponent, I want to put that exponent on both of these things. So I'm going to go -3 to the -2 over 4 to the -2. So the exponent goes to both things. Okay, so now let's make these positive. Okay, so if I want to make this one positive, it moves to the bottom. Now notice, I didn't make the 3 positive, I only made the exponent positive. Okay, and then to make this one positive, it moves to the top. So now I'm going to simplify. 4 squared is 16. -3 squared is 9. Now let me show you that in the calculator because some of you will put that in wrong. On the top, 4 raised to the second power is 16. On the bottom, if you put in -3 squared, it's going to give you -9. You have to put parentheses around the -3 so that it squares the 3 and the negative, not just the 3. Okay, so be careful there. Okay, so let's move into some of the kind of bigger ones. Okay, so I'm just simplifying. So here we've got a multiplication problem. I've got this thing times this thing. Okay, so you start with the numbers. So I'm going to start with the 2 and the -5, and I just multiply those together. 2 times -5 is -10. Okay, then look at your x's. I have x cubed times x. This goes back to our powers, our properties. I'm multiplying, so I add the exponents. This is 3, this is 1. Add them together, I get 4. I can't do anything else to that, so I'm done. -10 x to the 4th. Okay, let's try another one. Let's see what I've got here. Okay, so now I threw in 2 variables, 2 different ones, so be careful here. Okay, so I've got 4 times 3. 4 times 3 is 12. I have x to the first and an x to the -1. So if you need to circle it or something, circle it. Okay, I add those. So I'll write it out. 1 plus -1. Then I have a y to the first and a y to the 5th. So I go y to the first, and I'm going to add the 5. So let's simplify that. This becomes 12 x to the 0, y to the 6th. Now, I'm not going to leave it like that because, remember, anything to the 0 power is just 1. So really, I can just cross that out. So my answer is 12 y to the 6th. Okay, number 6. Okay, so we multiply the numbers first. -3 times 2, -6. Then I have x to the 5th, and I have an x to the 1st. I add those, becomes x to the 6th. Then I have this lonely y to the -2. I can't combine it with anything, so I leave it y to the -2. But we always want positive exponents. So it moves to the bottom, so it becomes -6 x to the 6th divided by y squared. It just moves to the bottom. Okay, number 7. I know we have a lot here, but there's just so many different types of examples. So just stick with me. We're getting there. Number 7, 3y squared to the 4th. Okay, so I have a power on the outside here. So everything on the inside gets the power. The 3 gets the power, and the y squared gets the power. Now, you don't have to write this out because hopefully you'll start to realize now I have power to a power. I multiply those. So 3 to the 4th, y to the 8th. And then we're going to simplify this. So in your calculator, you can put 3 to the 4th, which is 81 y to the 8th. And we'll leave it like that. Let's do another one like that, number 8. Okay, so everything gets the power. So the 4 gets the power. The a gets the power. And I'm going to go ahead and multiply this. 2 times the negative 3, so negative 6. And the b gets the power. Just put that there. So b to the 8th. Now, this is a negative exponent, so it needs to move to the bottom. 4 squared is 16. The b to the 8 stays on top. A to the 6 moves to the bottom. Okay, let's do, what number am I on? Number 9. Let's do some division ones. Okay, so just to review, division, when I'm dividing, I subtract exponents. So this is going to be x to the 5 minus 2, which would be x to the 3. Now let me show you what that visually looks like. What happens is here, I've got 5 x's on top, and on bottom I've got 2. Well, think about like go back to your elementary school when you're talking about things canceling. This cancels, and I'm left with 3 on top. Okay, so that's what's happening here. Now, we're going to get a little bit crazier here with some negatives. So let's do x to the negative 3 divided by x to the negative 6. Okay, I can't say it enough. You have to be careful on these. So many people will mess up the negatives here. Okay, I always do the top one, negative 3, minus the bottom one, which is negative 6. What happens here? I've got 2 negatives, so that becomes negative 3 plus 6, which equals x to the 3rd. Now, the other way you can do this one, I'm going to do it a different way here, is the first thing I could do is make these positive. Move the x to the 6th to the top and the x to the 3rd to the bottom. Now, instead of negatives, I've got positives, and I can do the same thing. 6 minus 3, so I get x to the 3rd. Whichever one works for you is fine with me. Let's do one more like that with some numbers in it. Let's do 15 x to the negative 4, y to the negative 5 over 3 x to the 0, y to the 3rd. Okay, so I put numbers in, but I also put 2 different variables. Now, the numbers you treat regularly. Look at 15 over 3. 15 divided by 3 is 5. Then let's look at our x's. I've got x to the negative 4 minus 0. And then look at the y's. I have y to the negative 5 minus 3. So I'm going to simplify that a little bit. That becomes negative 4. That becomes negative 8. I've got negative exponents, so they need to move to the bottom. So this becomes 5 over x to the 4th, y to the 8th. All right, number 12. I've got like 2 more for you. Maybe 3. Okay, so now I've got division, but I've also got an exponent on the outside. So the exponent on the outside goes to everything. So it goes y to the 3rd, then it goes over 2 to the 3rd, and then this one, x to the Now I'm going to multiply here. 2 times 3 is 6. There's nothing I can simplify here except 2 to the third is 8. It's the only thing that I can do. Let's do one more like that. Okay, the 2 goes to everything. So the 2 goes to the A. The 2 goes to the top B, which becomes 8, because I multiply 4 times 2, over the 2 goes to the bottom, and I multiply B to the 4th. Now, this one's not done because I should never have a B and a B. I should only end up with 1. So this is division. So I'm going to subtract 8 minus 4, which becomes a squared b to the 4th. So for tonight, well, for the rest of the class, on the worksheet, what I'd really like you to focus on is number 5 through 12. Okay, so we did kind of examples of all of those. They'll never be, of course, exactly the same, but I want you to try those 8. It's only 8 problems, so you can finish some, do most of it in class right now, finish the rest for tomorrow. This lesson is also on my teacher website if anyone needs to go to that and look at it.